Welcome to section 512. We're going to still talk about more solving. So now if we graph the following, y equals x. Now y equals x is a diagonal line with a y-intercept of 0 and a slope of 1. So since we're solving graphically, we have to be kind of careful on how we graph this. It's one of the downsides of graphically is that you really have to be careful on how you graph it. You could also use Desmos for this as well. Y equals x. And now the square root of 2x plus 3. Now the square root of 2x plus 3 is going to look like this. And Desmos would be a good method for this because it is a little bit tricky to see. We'll use Desmos in class to verify this. Now, here's our two graphs. When we solve, we're looking for the point of intersection. And these two graphs intersect at the point 3, 3. There is our point of intersection. Now, let's see what happens if we solve this algebraically. So what we can do is y equals x and y equals the square root of 2x plus 3. Since they both equal y, they both equal each other. The square root of 2x plus 3 equals x. To get rid of the square root, we're going to square both sides. So 2x plus 3 equals x squared. To quadratic, get it equal to 0, subtract 2x from both sides. And we're also going to subtract 3 from both sides. So 0 equals x squared minus 2x minus 3. So we can factor this. We get x and x. Now to multiply to negative 3 and add to negative 2, we get minus 3, x plus 1. So x equals 3 and x equals negative 1. That's interesting. When we solved it this way, we got two solutions. Now, when we look and check our answers, because we squared both sides, we added some potential error into the solving of it. So when we substitute, we always go back in the original. The square root of 2x plus 3 equals x. So now when x equals 3, 2 times 3 plus 3 equals 3. So the square root of 2 times 3, so square root of 6 plus 3, that's the square root of 9. 3 equals 3. That one's valid. Now, when we put in the negative 1, 2 times negative 1 plus 3 equals negative 1. So 2 times negative 1 is negative 2, plus 3 is 1, so it's the square root of 1 equals negative 1. But the square root of 1 is 1. That is not a true statement. So the negative 1 was extraneous. Our only actual solution was when x equals 3. That's our only solution. Because what happened is, actually, I'm just going to leave it at that. Our solution is x equals 3. Now, here's some other solving of some more complicated systems. Number 2. Y equals 2x squared plus 5x minus 3, and y equals x squared plus 4x plus 3. This is when two parabolas are intersecting. So now, since they're both equal to y, we can solve it algebraically by setting them equal to each other. 2x squared plus 5x minus 3 equals x squared plus 4x plus 3. If the quadratic, get it equal to 0. Subtract x squared. Subtract 4x. Subtract 3. So we get x squared plus x minus 6 equals 0. So now, when we factor, we get x and x. And to get that negative 6 and add the 3, we get plus 3 minus 2. So x equals negative 3 and x equals positive 2. Now let's check for extraneous. So 2 times negative 3 squared plus 5 times negative 3 minus 3 equals negative 3 squared, in parentheses, make sure you have those parentheses, plus 4 times negative 3 plus 3. Negative 3 squared is 9, so it's going to be 2 times 9, which is 18, minus 15 minus 3. Negative 3 squared is 9, minus 12 plus 3. So we get 0 equals 0, which is valid. That one's good. 2 times 2 squared plus 5 times 2 minus 3. 2 squared plus 4 times 2 plus 3. 2 squared is 4, times 2 is 8, plus 10 minus 3. 4 plus 8 plus 3. 8 plus 10 is 18, minus 3 is 15. 4 plus 8 is 12, plus 3 is 15. 15 equals 15. They are both valid solutions. Now, it's a system. So we should also be finding out what does y equal. So I shouldn't have circled that. So y equals, and it doesn't matter which one we go. Well, actually, it does matter. Excuse me. We're going to go in the both. So now, when x is negative 3, 2 times negative 3 squared plus 5 times negative 3 minus 3 equals y. And that is 0. So one of our solutions is at negative 3, 0. And when x equals 2, 2 times 2 squared plus 5 times 2 minus 3 equals y. That's when y equals 15. There's actually our 2 points of intersection. Negative 3, 0 and positive 2, 15. Let's go to the next page. Let's look at problem number 3 now. Once again, they're both equal to y, so we can set them equal to each other. Negative 24 over x equals the quantity of x minus 3 squared minus 13. All right, so to get rid of the fraction, what we can do is we can multiply both sides by x. Everything by x, excuse me. So they cancel. We get negative 24 equals x times the quantity of x minus 3 squared minus 13 times x, or 13x. I'm also going to add 24 to both sides. So 0 equals, now, it's going to be x times. Now, x minus 3 squared, off to the side here, x minus 3 squared is x minus 3 times x minus 3. So that's x squared minus 3x plus 9. So we get x squared minus 6x plus 9. And then we have minus 13x and minus 24. Now I distribute the x, I get x to the third minus 6x squared plus 9x minus 13x minus 24. 0 equals, now when I combine, I get x cubed minus 6x squared minus 4x minus 24. I got 3 terms I can solve by grouping. For the first 2 terms, x squared times x minus 6. Last 2 terms, negative 4 times x minus 6. Oh, sorry, that's the last number I added 24, excuse me. Plus 24 for the last one. All right, so now our common factor, x minus 6 times x squared minus 4. And I can keep factoring. 0 equals x minus 6, x plus 2, x minus 2. So now my solutions, x equals 6, x equals negative 2, and x equals positive 2. Now we also need to check for extraneous. So negative 24 over 6 equals 6 minus 3 squared minus 13. So negative 4 equals 6 minus 3 is 3. 3 squared is 9 minus 13. So I get negative 4 equals negative 4. That one's good. Negative 2. Negative 24 over negative 2 equals negative 2 minus 3 squared minus 13. So it gives me 12 equals negative 5 squared is 25 minus 13. I get 12 equals 12. That one's good. Now let's check the 2. Negative 24 over positive 2 equals 2 minus 3 squared minus 13. So I get negative 12 equals 2 minus 3 is negative 1. Negative 1 squared is 1 minus 13. Negative 12 equals negative 12, and that one's good. So all three of those solutions are valid. Now we do want to find our y coordinate for this, since it is the point where these are intersecting. So y equals, you can use either one of the equations. I'm going to use the top one because it's easier. Negative 24 over 6, which is negative 4. So one of our solutions, sorry for being all over the place, it's at 6, negative 4. Another solution, y equals negative 24 divided by negative 2, which is 12. So we're at negative 212. And y equals negative 24 over positive 2 is negative 12. So we would get 2, negative 12. Those are our 3 points of intersection. And those are the values of x as well. So let's look at problem number 4. When we see these, we want to isolate the square root, so we're going to square both sides. We get 5x minus 9 equals 121. Add 9 to both sides, 5x equals 130. Divide both sides by 5, x equals 26. Do a quick check. The square root of 5 times 26 minus 9 should equal 11. 5 times 26 is 130. So it's the square root of 130 minus 9. The square root of 121. The square root of 121 is 11. 11 equals 11 is valid. Now for problem number 5, that is a cube root. So to undo a cube root, we're going to cube both sides. So we get 2x plus 7 equals 3 cubed, which is 27. So be careful with that. Subtract 7 from both sides. 2x equals 20. Divide both sides by 2. X equals 10. And then we'll do our check again. The cube root of 2 times 10 plus 7. So we get the cube root of 2 times 10 is 20. 20 plus 7 is 27. And the cube root of 27 is 3. So 3 equals 3. It's a valid solution. Okay, and I will see you in the next video to do more solving. Thank you and have a good day.